Welcome to The Explainer. Today, we're going to follow a single application pod on its incredible and sometimes challenging journey. It all starts with a simple container, but its final destination? That's the demanding world of production in Kubernetes. Let's see what it takes to get there.
So, here's the thing. Creating a pod, that's actually the easy part. But making it ready for a real live production environment? Well, that's a whole other story. It needs to be secure. It needs to be compliant, and it absolutely has to be rock solid. Let's break down exactly how we get it there.
Our pod's journey begins with its very first checkpoint, and you could argue it's the most important one, the pre-flight security check. Before a pod can even think about going live, it has to pass a really tough security inspection. This part is completely non-negotiable. You know, our container images are kind of like layered cakes, with each layer being a different piece of software. A CVE, that's a common vulnerability and exposure, is basically a known security flaw. It's like a hidden backdoor that could be lurking in any one of those layers. And just one tiny flaw could put our whole application at risk. So how in the world do we find these hidden backdoors? Well, we bring in a detective. We use an amazing open source tool called Trivy. What it does is scan every single inch of our image and compares what it finds against a huge, constantly updated database of known threats.
And the process itself is just beautifully simple, but so powerful. It's a three-step, totally automated check. First, Trivy scans everything. Second, it compares what it finds to its database. And third, it gives us a crystal-clear report that tells us exactly what it found, all sorted by how serious it is. Nothing gets missed.
And here is the bottom line. See that red bar? Any vulnerability that gets flagged as critical is an absolute showstopper. If our pod has one of those, its journey to production ends right here, right now. This scan is truly our first and most important line of defense.
Okay, so our pod's image is scanned, and it's clean of any critical flaws. Phew, it passed the first test. But you know, security isn't just about the code inside the container. It's also about its configuration. Does the pod itself follow the rules of our cluster? It's time to meet the gatekeeper.
Every single thing you do in Kubernetes, whether you're creating, updating, or deleting something, it all has to go through this central gateway called the API server. And standing guard at that gate is something we call an admission controller. This is exactly where our policy engine, a tool like Kyverno, gets to lay down the law.
Now this is where the magic of a policy engine really shines, because Kyverno can play two very different roles. First, it can be a strict validator, just checking if a pod breaks the rules and denying it if it does. Simple. But it can also be a helpful mutator, automatically fixing small problems on the fly, making sure the pod is compliant without anyone having to lift a finger. All right, our pod has passed security, it's sailed right through the policy gate, it's almost ready for the spotlight. But you know, before any big show can begin, every great performance needs a setup crew to get the stage ready.
And that's exactly what init containers are for. Seriously, think of them as the setup crew for a big concert. They run first, they prepare everything, maybe they're downloading a configuration file or setting up a database, and only when their job is completely finished can the main performance begin.
And the sequence here is absolutely critical. The main application will not even think about starting until every single init container has finished its job successfully. And what if one fails? Well, the pod just restarts it and tries again and again until the setup is absolutely perfect. The show simply can't go on otherwise.
Okay, the setup crew has done its job and they've left the stage. But what about all the tasks that need to happen during the performance? For that, our application is going to need a constant companion.
This is the perfect job for a sidecar container. So if the init container was the setup crew that comes in before the show, the sidecar is like the roadie who stays backstage for the entire performance. It runs right alongside the main app, taking care of crucial background tasks like collecting logs or managing network traffic.
So let's just put these two side by side to make it super clear. Init containers run to completion before the main app starts, and they're all about one-time setup. Sidecars, on the other hand, run in parallel with the app for its entire life, handling all those ongoing background tasks. One is sequential, the other is parallel. Two very distinct patterns for two very different jobs.
And just like that, there we have it. Our little pod passed security, it cleared the policy gatekeeper, it was set up perfectly by its crew, and now it's running smoothly with its constant companion. It has officially made it to production. So let's recap this whole journey by looking at the 5 keys that unlock the gate.
So what are the 5 big takeaways? What's the playbook?
Number 1, scan everything. Always check your images for vulnerabilities. Number 2, enforce the rules. Use a policy engine to do the heavy lifting for you. Number 3, separate your setup tasks. Use init containers for everything that has to happen before your app starts. Number 4, delegate ongoing work. Let Sidecar Containers handle things like logging and monitoring. And the 5th, and maybe most important key, use these patterns, not more code. This whole approach keeps your main application clean, focused, and doing just one thing really, really well.
So take a second and think about your own projects. Which one of these patterns could you use right now? Could adding a security scan stop a crisis before it even starts? Could a policy engine save your team hours and hours of manual checks? Each of these patterns we've talked about is an incredibly powerful tool for building stronger, safer, and more resilient applications.